Good afternoon and welcome to the Measure Across America pilot program presentation. My name is Greg Driscoll. I have nearly 3 decades in the transportation safety infrastructure industry. I am considered an expert, an instructor, and an authority in the pavement markings and retroreflectivity industry. I have multiple traffic safety innovation awards and patents, and I'm greatly involved in traffic safety industry through active membership and participation in multiple trade associations. With American Traffic Safety Service Association specifically, I'm a member and leader of multiple task force and committees, including a member of the Pavement Marking Committee, chairman of the Pavement Marking Industry Advancement Subcommittee, and I'm the national chair-elect for the association. That's quite an honor. I am recently expanded my commitment to the transportation safety industry as a member of the Airfield Marking Certification Oversight Committee, where I can use my experience and expertise from the traffic industry to make airfields safer. Ultimately, I'm a student of both industry and life. Before I get started, I'd like to share this one thing with you. You see, you and I, we're in a unique position. You see, we don't have to run into a raging fire. We don't have to apprehend a dangerous criminal, and we don't even have to wear a helmet and carry a gun onto a battlefield. But every single day, we have the opportunity and responsibility of saving lives. Today, as we go through the numbers and the calculations and all these statistics that I'm going to show you, let us not forget the real reason that we do what we do. And that is to impact that ultimate statistic of over 4 million injuries and 40,000 annual deaths of our fathers, mothers, sisters, and brothers, even if it's just one. So what is the purpose of Measure Across America? Again, this is the pilot program in the spring of 2019. We will be doing the full program. The purpose, some people wondered, they want to know, were we trying to pick out the best materials? Were we trying to pick out the best states? Were we trying to expose roads that were not marked well? Well, our real focus and purpose was to advance the responsible pavement marking management. This is our ultimate goal, is that not just FHWA, Federal Highway Administration, or federal agencies across the world, but state agencies and local agencies all be more responsible for the pavement marking management. And I think that starts with an education, understanding of where they are and where they need to go. And then, of course, we in this industry need to help them figure out how to get there. Okay, now that we know a little bit more about us and the purpose of Measure Across America, let's continue the introductions by knowing a little bit more about you. Among the registrants of this particular webinar, we found that 44% were part of a government agency, 21% as a contractor, 16% were manufacturers, and 19% were other. And other we would consider usually are transportation engineers that are consultants or work for an engineering firm, and maybe some representatives out there of some different product and so forth. So thank you all for being on board and listening in. So as you can see, the majority is the government agency representatives. Next is the knowledge level of retroreflectivity. One of the questions we ask is, what level of knowledge do you consider yourself? We had 75% of you, 3/4, stated that you were a novice, and 25%, which is a good number, 25% are considered themselves as experts. So 1/4 of you, which is awesome because I love peer reviews. And even from the previous presentation I did, I have already gotten some feedback, and in fact, you guys should be excited because we did make some additions and some changes and some clarifications that we really were able to obtain out of the first set of feedback that we've got. So let's get started. So there are the 5 whys. Now, if you're in product development or organizational development, you may be familiar with this term. We're going to use it a little different. The 5 whys for us to get us started is 1, why did we choose pavement markings to focus on? Number 2, why did we use a retroreflectometer to focus on them? Number 3, why a mobile retroreflectometer? Number 4, why this specific retroreflectometer, the LLG7? And then, of course, the big question is, why Tesla? Okay, let's start with why pavement markings. First of all, it's expertise. It's what we know. 3 decades into the pavement marking industry, both as contractor, supplier, designer, developer, manufacturer, it's what I knew best. And so that's what we tend to lean toward is are those things that we know best. Efficiency. Pavement markings are one of the best bangs for the buck. It's a low cost roadway infrastructure safety measure. Think about the cost of a mile of roadway and then think about the cost of a mile of pavement markings. It's a very small fraction, small percentage of the cost of the roadway itself. So therefore, the safety that it brings, that added to the cost, is just makes it extremely efficient. Last is it's effective. So we have expertise, efficient, and it's effective. It's effective both for human driving and for automated vehicles. In fact, General Motors stated, along with, I think you can find that most any of the auto manufacturers would say the same thing, is that the most important infrastructure element on the roadway today for automated vehicles are the pavement markings. At this point, if you don't have good pavement markings, you will not have good AVs. Next is, why a retroreflectometer? Well, first of all, it's objective. There's no visual subjectivity. It's not dependent on the eyesight of the individual that's viewing it. It's not determined by maybe a bias inspection, whether good or bad. It's also safe because a retroreflectometer can be used both day and night. There's no need for just nighttime inspection in most cases. And it also assures visibility for the motorists, so it makes the road safer as well. And of course, it's accurate. It's numerical value standardized testing. It's a number. It's a pass. It's not just a pass fail or it looks good or it doesn't look so good. It actually produces a number that we can use. Most importantly, that we have to understand is what you see is not always what you get. And a retroreflectometer exposes that. Let me demonstrate. So as you look through this video as it plays, you'll see these markings are very nice. This is on a newer road or a newer surface, but look at what happens. These things are turning 60 to 100 millicandela per meter squared per lux. This is an incredible pavement marking that we saw as far as in the daylight. And here, let me pull that back up. You can see this nice contrast, beautiful yellow lines, nice edge lines. These are 4-inch. I prefer 6-inch because if you start with 6, it'll go down. If you start with 4, it goes down. So obviously, the wider you start, the longer that you'll have that good visibility. But what's cool here is they've actually put edge line, which is really important for AVs. It's very helpful for them. It's not required all the time, but it is definitely helpful for a vehicle, AV vehicle, to see an edge line. So the edge lines are bright, nice contrast, beautiful daytime visibility. But then again, when you go into the meter and you look at it, this is what it's going to look like at night. Now, if I was to go out there during the day, I'm going to assume that these pavement markings, which must have been what happened, inspector came out and said, gosh, these lines look great. But what they didn't realize was under the cover of night, they were very poor in their retroreflectivity. So the issue is that a retroreflectometer will detect this when the eyes don't. Why mobile assessment? Mobile assessments are incredibly safe. There's no required maintenance of traffic, either static or mobile, which is pretty cool. So there's no barrier walls needed, nor is there any attenuators, mobile crash attenuators that are required either, because what we can do is strap this onto the vehicle and then travel at vehicle speeds. There's no traffic interruption whatsoever. And the great thing is there's no workers on the road. I like that. Next is it's incredibly efficient. Hundreds of line miles can be measured in a day. In 3 days, we measured about 1,100 miles, as we'll talk about in a moment. So it's incredibly efficient, and it also can provide complete comprehensive assessment very quickly. So it's not just about the retroreflectivity. That's, of course, the most important part for nighttime visibility, but there's a lot of factors that affect that retroreflectivity or that visibility. With this particular unit, we were able to get the width of the line, the retroreflectivity, the distance that we traveled, the contrast. We were able to have GPS coordinates so we could map it out and know exactly where that bad line was or where that good line was. And of course, with this particular unit, as I'll talk about in just a moment, we were able to get color to be able to compare its color. So let's talk about that. Why the LLG7C? C standing for color. Because it's just like any mobile, it's safe. It's safe both for the operator, there's no feet on the street, and it's safe for the motorist, so there's no traffic interruption and so forth. Also, of course, it's because it's smart. Its accuracy is incredible. It's scanning the lines or the pavement at about 400 times per second with a laser. And it's just incredibly accurate at 30-meter geometry. We'll talk about some of the components that cause that in a few moments, why its accuracy is so good. Also, comprehensive data. We're able to, with the LLG7, it was able to provide us with a tremendous amount of data on these markings. And then lastly it's the only instrument that we could get, a mobile instrument that would provide a color measurement as well. And of course, it's simple. I'm kind of a simple guy. I'm from the great state of Tennessee, and I like things simple. And in this case, it's easy to set up. We were able to set it up on the vehicle after the first setup. We were able to set them up in about 7 minutes, I think is what we were averaging when we were calculating that. Operation, as you'll see in a few moments, it was simple to operate, and what's really cool is the incredible reporting that we're able to get. Why the Tesla? Good question there. Complementary technologies. Basically, it was kind of cool to use one of the highest tech vehicles with one of the highest tech mobile retroreflectometers. Really, also, what we found was, of course, the Tesla provides added safety. With its sensors and its autopilot system and so forth, we found that it was very safe to operate this on the roadways along with this instrument. It actually manages your lane positioning, which is really cool because that means I don't have to focus on making sure that, that the meter is, we have a 3-foot span that this thing's scanning. Now that gives us a lot of room when you think about a 6-inch line, but it's easy driving 60, 70 miles an hour down the road to veer off that line or something. So, you have to monitor that. And having the Tesla was pretty cool with the autopilot. There was no stress on that at all, of course. Vision comparison. This was really one of the main reasons. What we wanted to do was compare what I saw on the road, or what we saw, and what the meter saw and what the car saw. So with that way, we could kind of get a comparison. I'll talk about the struggles in a little while, or maybe even it would be considered a surprise. This really wasn't extremely successful in bringing us data on this because, frankly, the autopilot rarely ever failed on us, even when the lines were very poor. But we'll talk more about that in a few moments. Oh, of course, the cool factor. You can't imagine stopping at these charging stations or stopping in the grocery store and you have this this laser attached to the side of this pretty cool car, and Lord help us if we open the doors. It definitely was. It was a lot of fun. So let's be frank, it was cool as well. Next is I want to demonstrate or show you about the route here. We went from Jacksonville, Florida to Williamsburg, Virginia. Why did we check those? Well, we're from Jacksonville, and that's where our headquarters is. And Williamsburg is where the American Traffic Safety Service Association mid-year conference was. And we thought, well, we're going to probably drive up there anyway. Let's strap on the LLG7 and do a pilot for our effort of Measure Across America. Now, Measure Across America, this is the pilot. This is kind of the short version. This is where we learned a lot about what we can do, what we can expect, and so forth. But we will be doing a coast-to-coast Measure Across America in the spring of 19. So we'll bring that up here in a few moments. So our route was about 1,100 miles. We went across 38 different roadways and through 5 states. We also rode 3 road types intentionally. First of all, we did non-interstate northbound. So we avoided the interstate all but I think about 1.25 miles. At one point we had to get on the interstate because we had to go over this waterway that would have taken us about 100 miles out of the way to get around that. So we took that 1.25 miles. But other than that, the entire northbound trip was done in non-interstate roadways. And we classified them between under 50 miles an hour and over 50 miles an hour. Now let me explain why we did that. We see a lot of measurement requirements coming down, especially when you look at the FHWA requirements. And what they're doing is they're saying, okay, we want this reflectivity for roadways under 50 miles an hour, and we want this reflectivity for those over 50 miles an hour. And at one point there was a version that included an extra or a raised retroreflectivity requirement over 70 miles an hour. Then we have, of course, the interstate. And interstate we did southbound, interstate was extremely easy. We did find a lot of surprises, though, when we compared the 2 roadways. Things didn't turn out as we kind of assumed they would. Let's talk about the attributes. So this long list is all the things, all the attributes that we wanted to know about the measurements we were taking. So with the LLG7, we identified the state road name, or the state name, the road name, and the GPS coordinates. Anything you see with an asterisk is something that the machine automatically collects. So it monitored our GPS coordinates. Now, why this is important, of course, because we can put it on a map. So we can look for the hot spots, the cold spots, the failures, the great lines and the bad lines. So it's very cool to be able to go in there. And you can kind of zoom in, and sometimes, like we did some surveys up in Michigan at one point, and all of a sudden there was this area of this route that was failing. Everything was fine, and then there's like this area of failure, and you could see it on the map. And all of a sudden it turned red. It went from green to red, and it was just so long, and then it went to green again. And our first look, we zoomed in through Google Maps. We were able to look in, and well, first thing we did, we went to our HD video. And we looked at the road, and the road looked same because daytime visibility really wasn't affected much. But what we did know from that and from the Google Earth was there was a trucking, like a logging station there for log trucks. And we thought, okay, well, something's going on there. Well, what we found out was when we went out and said, okay, let's take a closer look, we found the beads had been knocked out of that area, the glass beads. So there was no reflective line there because those trucks were wearing and tearing on that line coming out and going down that road. Anyway, a very cool stuff that you can do because you have that GPS coordinate. Next is environmental monitoring. This is super important because one of the videos you'll see, we have about a dozen videos that we took during this trip, and you'll see some of them in this presentation, but one of the things you have to be really concerned with when you're measuring retroreflectivity is that if you want proper representation of that line, as it is normally, you can't do it when it has dew present, because dew will knock that reflectivity just completely down next to 0. So you need to make sure that you don't have a high humidity, low temperature situation, or just what you're really looking for is that humidity. So if you have a section of line that doesn't look good, you can go back and say, gosh, I did those at 6 o'clock in the morning. Let's look at the humidity. So it does record that. Next is the attributes or the conditions, and this is where we get our road conditions, our road type, and our material type. And these are not the buttons that we used. These are user defined. So I can set those up, and I'll show you more about what we did have. For instance, we had over 50, under 50 interstate. We had different types of materials. It was thermo paint and tape, and then we had oh gosh, we had RPMs present. We had AV failure, so that we could click it, and so these buttons are pretty large, so they're easy to click on. You'll see it in the video here in a second. Next, we had the striping type identifier. It tells us if we're measuring a solid line, a skip line, a double solid, right skip, left skip. And of course, a retroreflectivity. This is live. This is what we're reading at the moment, and this is just kind of a history, a streaming of retro data. And then this was really cool. We have nighttime color, so we're able to read it. It actually will tell us if it's yellow, white, or if it fails. This was really helpful in the end. Actually, I used it for something that I hadn't really thought of in the past. I'll share that with you on successes, I believe, in the end. And then a nighttime contrast. This tells us how much contrast we're seeing. Also, the width of the line. Super important. This one was 6 inches and 5.7 inches. It was a double yellow line. I can tell that by reading the screen here. And this is RPM count. RPM count was really interesting. This will detect RPMs. So it doesn't measure them because we have a different set of angles that we use for RPMs versus what we use for roadway markings. We're trying to work on that a little bit so that you can actually measure these with mobile, looking for correlations and so forth. But we're not there yet. But we went to do the RPM count, but my problem that I ran into, which I'll share again later, is that there's a lot of times when we didn't know if there were supposed to be RPMs there, like if there had been, because they were in such poor shape. We saw a lot of that, especially on the secondary roads. Mile marker identification and controls. This really helped us maintain or manage and monitor our distance. This was a cool thing. This is the automatic positioning system, which really helped us in maintaining accurate geometry. So you can imagine retroreflectivity is about light going out in a certain angle and coming back in your detector or your human eye, in this example, is at a different angle. So it's all about the angles. So you can imagine as the machine, for some reason, if the machine gets closer to the ground or further from the ground, that angle changes. So you have to be really careful with that. So what they did with this is they put these two lasers on the bottom, and this thing manages its own height. Now let me tell you why that's really cool, is because in the old days and with some other units, if you, for example, if you have two men riding, or whatever, two women riding in a vehicle, and they're going to be monitoring, like we used to have in the old days. We had this big van and we had all this computer equipment, and you had to kind of fill it up with fuel and put everybody in it and then set the height on it, right? And because that was the geometry it had to be at. The problem is that if you change those persons, or if you burn the fuel, which you light in a vehicle, which you don't have in a Tesla, or if your air pressure changes in your tires because you've been driving all day and it's expanded in there, you're going to mess with your geometry. What this does is says, hey, I'm not exactly where I need to be. So it will actually lower and raise. It'll even tilt back and forth as well as you're operating the vehicle and as that vehicle progressively changes in its height from the ground. So this is where I'm operating it as we're driving. So this is the stripe type, color. These are those settings that I was talking about. We're trying to make sure we maintain and you know what type of road it is and what type of marking it is and so forth. You can see the meter, it's going there now. I think we've got it looks like a solid skip going on there, probably a right hand skip is my guess. And here's your meter reading, and you'll see more of those in a moment. But this is pretty cool. It just makes everything easier. It was for us when we did this program. It made it easy to reach down and touch that. The other thing that made it easy was this. That it's on autopilot right now. That little blue light there tells me it's on autopilot. So I've got my hands on the wheel for safety, but it's actually navigating itself. It's keeping in its own lane and managing the lane, and so that was extremely helpful. Highly recommend using a Tesla. It's not necessary at all, but highly recommend using a Tesla in this assessment process. It was pretty cool. All right, so we're going to talk about the miles. Let's get to some of the statistics. Miles we measured. So we measured about 1,100 miles. 152 miles of it was under 50 mile an hour non-interstate roadway, mostly suburbs or even in towns. We did a lot of driving through some small towns and so forth. We did 426 over 50 mile an hour non-interstate roadway miles. And then interstate miles, we did 525. So you can see here it was a little bit longer going up because we were taking those secondary roads and then our non-interstate, I'll call them secondary probably several times, so forgive me if you don't like the nomenclature I've given it. So these secondary roads we did, 570 something, and it's 525 when we go straight down the interstate. A little bit more efficient in the miles with the interstate in this particular case, not always the case, but in this case. You can see here the majority of our miles that we did was in the states of Georgia, which is 18% here, North Carolina, which is 35%, and South Carolina, and 34%. We did touch into Florida and into Virginia. Those were on the tail end of each direction, and so they're not well representative numbers. These are pretty good though. These are pretty solid for that area and for that section of the state. And so forth. All right, let's talk about line types. Remember, this is the stripe type, and what we found was you see here we had the ability to call these things out on our panel. We have single solid, single skip, double solid, and right skip and left skip. You'll notice that the majority, 55% of our readings were actually taken on single solid lines. Now, why that is because if you remember, we did 525 miles of the interstate system. And of course, that's all we measured. You know, something I want to make sure that everybody knows, and I apologize for not mentioning it earlier. Everything that we're going to see here is a yellow line, very intentionally. So what we're doing is we're measuring center line for a number of reasons. One is because the center line is what divides the traffic most often going against each other or traveling in opposite directions. So that's the most critical line. The other thing is that we often find, except for some cases, we'll talk about those, we often find that the center line will be worn faster than the edge line. So the center line really gives us a good sampling of how the overall markings are. We can take measurements of both center line and edge line. We just do what's called a tandem, and we can put a machine on each side, run it from the same panel, everything else, which is kind of cool. But in this case, we only did the center. So most of it was single solid, and then the next chunk was in the double solid and the single skip. So you can see that 30% of it was, you can see this is reflection, pardon the pun there, is a reflection of what type of roadway we were on there. You can see this obviously is going to be a lot of your secondary roads here. And then 8% and 8% look like a pretty good split on left and right skip. All right, now we're going to talk about valid measurements. We call them valid scans, and the reason we do that is because, remember, this machine is scanning at 400 times per second. So what it does is we set it, we say, okay, if it's 25 millicandela or higher, we're going to call it a line. If it's lower than that, it could be a reflection of the pavement, it could be all kinds of things. So we set it at about 25. So when it says, okay, I found something that's more than 25 millicandela, it'll come back and it'll say this is a valid scan. So in this trip, we've had 16.5 million valid scans, 16.5 million measurements, basically. Now, of course, that's a tremendous amount of data. So we said, okay, what we're going to do, though, is that we want to average all those scans every 0.05 miles, every 264 feet. Now, that's an unusual thing to go to that small of an increment average. Normally, agencies are going to tenth miles. In this case, because we're going to be on these secondary roads and there's so much change that happens on these secondary roads, I wanted it to be a little tighter. And then when we started traveling the interstate miles, I thought, well, you know, we're already there. Let's go ahead and keep it. So you can imagine, I think we ended up with 22,000 what we call records, which is those averages. Next is valid scans per mile. Of course, if we have 16.5 million, we did 1,100 miles. It's about 15,000 scans per mile that we were able to get. Now you can imagine trying to do this with a handheld. Right now, most agencies are saying, okay, with a handheld, do beginning, middle and end, and average those numbers of a mile long. So that's 3 measurements in a mile. This is doing 15,000. So when we talk about comprehensive, this goes back to the use of a mobile instrument. It's extremely comprehensive. So 15,000 scans per mile. If you look here, 8.5 million scans on the interstate. We did over 50 miles an hour. We got 5 million valid scans. And in non-interstate under 50 miles an hour, we've got, excuse me, 3 million scans. All right, next, what everybody probably came on here for to begin with, but only part of the information that we were able to obtain, is the average retroreflectivity of the markings. So first I'm going to break it out by road type. So we had an average of 152 millicandela per meter squared lux on interstate roadways. We had 143 millicandela. I'm going to, for all you engineers out there, or especially the scientists, I'm going to shorten this. Every once in a while I may still catch myself doing it, but 143 millicandela, we're just going to say that. So I know that's a little improper, but we're just going to say millicandela. So over 50 miles per hour, we had an average of 143 millicandela. And then non-interstate, we had a non-interstate under 50, we had 137. One of the things I do like about this is that I saw as the speed increased, so did the retroreflectivity. So that was a positive surprise. Another positive surprise, remember this is all yellow, okay? So another positive surprise to me was these numbers down here, especially this 143. I was pleasantly surprised that these were as high as they were because I expected them to be lower. I was negatively surprised about this number, 152. I had really hoped that, you know, we just make this assumption that I know we have more traffic on our interstates, so therefore there's more wear and tear on the markings. But you know, when I think the reason I wanted to do these off highway or off interstate miles and roadways was because I really had this assumption that the markings were just going to be pretty bad, and they turned out to be not so bad after all. But I expected that the interstate was going to be pretty awesome, and 152 is just not to my level of what I would call awesome. So that was kind of a little bit of a negative surprise. Okay, now we're going to talk about levels for a moment. So what I did was we created this bucket system. So by roadway type, we're going to do by roadway type again. And we created this bucket system that said these are buckets 0 through 6. So there's actually 7 buckets here. So bucket 0, this blue bucket, is going to be under 50 millicandela. Now remember we set our base at about 25, so it's really 25 to 50. And then we went from 51 to 100, 101 to 125, 126 to 150, 151 to 200, 201 to 250, and greater than 250. So let me explain why we created these buckets this way. If it was up to me, I would have, if it's solely for my evaluation, I would have said 50 to 100, then I probably went 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then 5 plus, because my expectations are a little higher than 250 as being the highest level. So that's number one. Number two is I wanted to have these small increments, and the reason is because I really wanted to demonstrate to agencies, including FHWA and state agencies, and even cities and counties, that minimum retroreflectivity, right now we're looking at a minimum retroreflectivity by FHWA at around 50 on certain roadways. That's a really low reading. And there's a concern, I'll show you that in a few moments why that's a concern. But so what I thought was, okay, let's put these in smaller buckets, because I don't think I can get agencies to bump up 100 millicandela as easy as I can get them to bump up 25 millicandela on their minimums. So that's the reason I did it. Yeah, it's a little, you know, yeah, I'm just trying to make the roads safer, guys. All right, so non-interstate miles. So we found about 24% of the non-interstate miles were under 100 millicandela. So that's a big number. But what's cool is that means that 76% were over 100 millicandela, which is far greater than the current FHWA requirement that they've put forth for comment. So we can see that there's, the roads are already, the existing roads already have, in this area of course, already have retroreflectivity over 100, 76% of those roadways. So very nice to see that. Interstate. This was disappointing. So you have 24% were non-interstate was under 100, but yet 32% of interstate were under 100. That hurts a little bit. That's a little scary when you're driving. Now you have less distraction. You have, your roads are more straight, but you also have much higher speeds. So it kind of balances out as far as the safety goes to some degree. Yes, rural roads you have a much higher degree or opportunity to die on a rural road than you do on an interstate. But this case, I was not impressed with this 32% being under 100 millicandela. That concerned me. So we're going to use the same buckets, and we're going to look at by the state. And you can see this is out of 100% of the markings that were measured. What you'll find is, again, remember Florida and Georgia are not well represented in this particular pilot project because much less miles were measured on there. I think Florida was maybe under 100, Virginia probably under 100 too, as well. South Carolina, North Carolina, and Georgia, these are good numbers here. You'll see as far as a good representation of the roadway systems that we were on. And what you'll find here is that about 25% down here, about 25% in Georgia, a little more in North Carolina, and almost 30% of South Carolina's roadways were measuring under 100 millicandela. And so this is a nice little graph that we can take a look at and see. You'll notice that a large portion of Georgia actually was in the 250 or greater. As a matter of fact, it's the largest portion. And then secondly would be the South Carolina market as well. South Carolina was interesting. We'll be showing you some of those measurements. We had some really good retroreflectivity, but we had another problem there. So stay tuned. Standard deviation. Okay, so what the machine does is it actually measures the deviation, and it's looking for consistent or inconsistent retroreflectivity. What can cause this longitudinal inconsistency is application. So if it could be the coatings, it could be the beads. During application, there was an issue with the sprayer, and it would get like you'd get the right amount of coverage, and then it reduced that coverage or something of that sort. So it made the paint thin, thick. And if that happens, then you can have a bead embedment issue. And also, you could just have a bead problem. So that's usually what causes that. That's one of the things, application. So you can find on a new line, you can find some significant deviation. What also causes it is wear. And that wear can be on curves. This is where that edge line I was talking about, that center lines were representative. On curves, there it's not very well. It could be, but a lot of times when we curve, we're going to stay on that edge line more than we're going to stay on the center line on a curve. It's just our nature of driving. And then cross traffic, for instance, it's where driveways and stuff where cars are pulling out, that'll cause deviation as well. We found that the deviation in this particular data set, 22% there was a 22% deviation on interstate, 33% on the over 50, and 31% on the under 50. So this is, this is important to look at just to make sure that we're not getting a bright, dull, or high reflective, low reflective. And that's what we're looking at when we look at deviation. We also, by the way, we do lateral deviation on airports and runways now. We found that important because a 6-inch line is pretty easy to get, get very little deviation across the line, unless there's an issue with with a blown tip, and it's feathering out the edges, and the beads aren't doing right. But we can pick that up on width here in a few minutes. But deviation is not a big issue usually on roadways. Where it is when you have a 30-foot wide marking, and so we can actually give a score for that deviation across. So the next topic is nighttime color. So this is we're going to first talk about yellow fail colors. So first of all, let's talk about wrong way driving. Wrong way driving, according to TRB in 2016, a study they did 1.34 fatalities per wrong way fatal crash. So these are deadly, and a lot of you guys know it because you're doing all these studies. Wrong way driving is deadly. We're working on some really cool stuff, some really cool innovation. So is the industry in general, constantly working on trying to prevent these things. But one of the easiest and most standard method here in the United States to keep these from happening is making sure our yellow lines are yellow. Yellow lines obviously divide traffic going opposite directions. So when there's a yellow line, you know when you cross that yellow line, you are in danger of a head-on collision. So out of all the things we're doing, we need to remember the basis or the basic function of a yellow line, and it's to keep people in the right lane, in the lane that they're supposed to be for that direction that they're traveling. So here is this, a little hard to see, but I want you to see this blue high line. This means that, geez, this thing is, well, there it is, 384 millicandela. Wow, 384 millicandela. This is a yellow line. It says here, and over here it says fail, color fail. So although this center, this looks like a left solid line, so this must have been on interstate is my guess, is this thing was popping on retroreflectivity. And that's a term I use from the airport community, airfield community. We've heard of the stories of the inspectors coming out and saying, "Hey, I want these lines to pop." I'm like, "Okay, what is pop? What is pop to you compared to me?" It goes back to why we use retroreflectometers. Sorry, I digress. So failure of color, even though you have high retroreflectivity. Now, failure of color, why it's so important in yellow is this. This is the ASTM D6628 nighttime color chart. And what it's done is it said, okay, we've defined this area as yellow. We've defined this area of white. So when the LLG7 went through and it measured its retroreflectivity, it's also measuring its color and it's plotting it. So the problem that you have is you can see these are all yellow lines. This one's on the edge of yellow. These are falling out, actually going toward purple. They're getting darker, probably through oxidation, dirt, whatever it might be. This is the dangerous one. When that yellow bleeds into white,
showing up on that screen,
this is what you
but
get.
That looks like a white line,
so
which would, in fact, make me think that it's okay to be over here.
But because they look
now,
white,
fortunately, there are some retroreflective pavement markers, raised pavement markers along the way that are showing amber, but you can see there's very few. They're kind of far from between. And you can see here that the yellow is failing. So it is not in the yellow color box. And I mean, this is consistently failing.
That line probably looks awesome. And we've got some footage of that again in our videos, in our video bank. If you go to our YouTube channel, of showing you a daytime yellow that looks beautiful, but then it's not reflecting yellow because this is about nighttime color. What color is it reflecting? So we've got this 200 millicandela reflective line, but yet it's coming across and failing in color. There's some questions. There's some questions about that. You know what? Let me come back to that in a moment. All right, road type. By road type, we had 15% of interstate yellow lines failed the color, 22% of over 50 failing color, and 23% under 50 failing. By state, again, Florida and Virginia not well represented here, but you can see that a significant portion, we got 20% of Georgia, around 17% in North Carolina. Look at the spike here with South Carolina. This is what I was talking about earlier. They had really good retroreflectivity, but in doing so, they were able to they kind of had to forego their color Now, they didn't have to, and that's what I was saying. Let me get to it. So the question often is, when we look at these lines, we think, here's one of the problems. This is why one of the reasons that new yellow fails. One of the reasons that new yellow fails is because we're so focused on getting that high retroreflectivity that we'll stop at nearly nothing to get it. So both, I would say manufacturers, contractors, everybody's involved in this. So a lot of times the closer to white we can get that yellow, the more reflective, the higher retro numbers you're going to have. It's just natural that because it's filtering, as you go white, it filters less light, puts more light back to the driver. The darker you go, the more light is filtered, so the less light's going to make it back to the driver. So it's a natural thing that yellow would normally reflect less than a white. But it doesn't mean that you have to give up retroreflectivity. Please understand that. This is about quality and proper pigment. This is about quality and proper bead embedment. It's not just that, hey, you can't get yellow very high. I'm seeing yellow. I can see yellow at 1200 millicandela and still produce a nice yellow color. Okay, so, but what we see a lot of times is a little bit of maybe a cheat going on. You know, if I take yellow paint and I mix a little white with it, I'm going to bring its retro up. There's no doubt. Or if, you know, so we have to be careful to make sure that we have a nice balance, and that's what I'm going to talk about here in a second, that we have a nice balance of a color and retroreflectivity. Is it all about yellow? No. So for your Europeans, we have a few of them online here, which complain that we use yellow. Why do we use yellow? Well, I showed you, because of wrong way accents. We want to prevent those. But look at this. This is a line that it's the same material, and we have 150 millicandela on the front section. We have 40 millicandela on the back section. This is a white line. Now you can imagine what this area is going to look like at night on, this is a concrete surface, but on a concrete surface, or worse yet, a oxidized asphalt surface. Your contrast, your nighttime contrast, your visibility of this line is going to be minimal. So we have to be careful as we look at creating minimums. If we get them, it takes light, as you'll see here, it takes light to produce color, because all color is reflected light. So we have to understand that the less light that we have, the less light that we're going to return, the less light we're going to have reflect back to the vehicle, the less color is going to be transferred. So we have to understand that we have to balance that color and the retroreflectivity. The retroreflectivity creates the color. So you have to be very careful when you start thinking about minimums, because if you don't create color, you're not going to create contrast, and you're going to have some problems with visibility. Line width average. So understand this is nighttime width. Now, why is that important? What do I mean by that? So daytime, I can go out there and take a measure, and I can a ruler, and I can measure, and it says 6 inches on the dot. Very cool. Okay, that's great. But at nighttime, I may get 4 inches. Well, why would I only have 4 inches? Well, mostly because of bead distribution across the line. So I see this a lot, especially in the airfield. But I see this where, for instance, if they're doing an airless, they're using an airless machine and they use a architectural tip. Architectural tips are heavy in the middle and they feather on the outside. Or it's a striping tip, but it's blown. So it's the same thing. It's going to have a lot of paint in the middle, and it's going to be kind of feathered outwardly. So those edges, if they're putting down their paint at a certain millage, the center is going to catch the beads, and the beads are going to embed properly. They're going to hold in there, and they're going to reflect properly. The edges may not. So that's one reason, and I'll kind of go over that here in a second anyway, of why you could have a nighttime width issue.
These lines are older, and they've never been smaller than 4 inch. My guess is that's where they started. But you'll notice the width is saying 3.3 inches on the left and 3.6 inches on the right. That's the average over the last distance or so. So 3.3 inches is quite a bit smaller than an already small 4 inch line.
6 inch lines for purpose of human vision and AV vision. I think that we're going to see, as we put in these high def cameras in these cars and they're starting to look further, I think that we're gonna see a greater need for these wider lines. Right now it's hard to tell because these things are short distance cameras in most cases. The sensors go further, but the cameras are really tight to the car right now. So the width doesn't make as much difference now as it will in the near future and as it does with human vision. But you can see that these probably started out at 4-inch lines. And the problem is that if you start out at 4-inch line, it's easy to get that line too narrow. And it's easy to intentionally or unintentionally make that line a little narrower. And you can imagine if you reduce the line width by 20%, you save 20% on your materials, right? So it's very important that you get that complete width. So you have two things. One is it could be applied improperly. In this case, let me go back to the statistics and then I'll get to that. Interstate miles, we found interstate was an average of 4.79. Now most of these interstate miles started out at 6 inches. You can see the over 50, 3.69. That's really not too bad if they started out at 4-inch. Some states like Florida has gone to 6-inch only for their state roads, and many other states actually. So if these were 6-inch lines, these things were really worn, because what happens a lot of times is these lines are wearing from the edges. Okay, back to the application. So I explained that how this can happen through application. I explained the feathering of the paint. It could be that the bead dispenser wasn't working properly, wasn't spreading the beads as well. It can also just be the material's age. So the issue with the materials, let me go back here. The material's age is an issue, because normally lines tend to wear from the edges in, especially like alkyd thermoplastic. You'll see that a lot. It'll just start wearing on the edges, and the next thing you know, years down the road, not really the next thing you know, but years down the line, you'll start seeing this thing get so narrow that you could have a 4-inch, started out at 4-inch, and now it's measuring at 2 inches. We see a lot of that. So age can definitely make a difference. So how does it affect the AV, as I was talking about? Now, not so much because of our short-range cameras, but in the future it could be a big issue. Kind of got ahead of myself on that one. Material type markings. So here's the statistics. The official statistics is we measured 850 miles of thermoplastic, 290 miles of paint, and about 16 miles of tape. Now, as you all know from the introduction, I have 3 decades in pavement markings. I can look at a marking and I can probably tell you pretty much what material it's made out of pretty quickly. The problem is when you're driving 50 to 70 miles an hour down the road, it gets a little tricky. So I will tell you that out of all the statistics that I have in this is probably the least reliable. Tape was fairly easy, but the problem I had, really, quite honestly, was I couldn't tell a lot of times, because a lot of times there's paint and thermo. Sometimes it's paint that's put down for temporary striping, and then the thermoplastic put over for permanent. So you see this little edge, you can see that there's 2 different products there. But sometimes it's also that there was thermoplastic there, and they coated it when that thermo reduced its retroreflectivity to a certain level. They went through and they refreshed that line with paint. It was oftentimes hard to tell, driving at the speeds we're driving and so forth, without getting out of the vehicle, what came first, the thermo or the paint. So it was that proved to be a little bit of a challenge. This is
and here, look down at the meter real quick. Right there, watch it jump.
What I'm doing
there, so now watch it jump.
I'm demonstrating. Okay, see this 265, 256. All right, look at where it was.
Look down at the meter real quick. Right there, watch.
Here, look at that, 110 or 116.
And here, look down at the meter real quick. Right there, watch it jump. All right, so now we went all the way up to 280, and we're dropping down now to 75. What we just did was we went across a bridge.
We just witnessed? What we witnessed was going across a bridge. We were in a painted section, I believe it was. Could have been thermo, but anyway, it was probably paint with those numbers. So we were in a painted section all the way up to the bridge, and then as soon as we hit the bridge, we hit structured tape. and boom, it jumped up to 265. I may make friends or enemies here, but the 16 miles of tape we did, it was all pretty good. 265 was actually on the low end. We saw much higher numbers than that on a lot of the tapes. The structured tapes are definitely good. They're just if you want to know more about my opinion on tapes, paint, and thermo and other products, be sure to watch some of the videos, and you'll see my thoughts on that. Again, I make friends and enemies all the time, so check it out, and remember that is my opinion, and you can take it for what it is. All right, next, day-night effect. So how did the day and night affect us in our assessment? First of all, it didn't really affect us at all in our measurements, because we can measure at any time with that LLG7 specifically. We can, and many of the mobiles, you can measure day or night. It doesn't really matter. There's a couple out there that you can't. But 78% of our measurements were during the day. 22% were after sunset. So we were able to do that without a problem. So it didn't really affect us there. But there is an effect not on the LLG7, but there's an effect on AVs. And this is the really reason you see these numbers are 87, 90. They're not all that great. Here we're jumping up to about 100. Okay, look out at this road. We have the sun coming down on the roads, and we have a serious glare issue going on. You can't, and I'll pull over there and see if I can pause it. There are no markings from where we stand. It's really hard to see them. And the reason is because we're getting significant sun glare. Well, not only does it confuse us, we use in the daylight, we have so many other cues, visual cues. We know that I see this vehicle coming, I see it's a wide road, I see guardrail on my right, my left. I know even if there's not a marking there, I know I better stay over here on the right side, especially in this particular case. The vehicle has a little more trouble with that because it can't see that line a lot of times. So what I'm expressing here is I'm talking about the here. Okay, now this is outside the glare. This is the same road. Now we have different marking. This is a double yellow. Oh, doggone it. Let's try that again. All right. Anyway, all right. Well, I'm not going to sit here and, oh, there it is. So you can see this nice double yellow edge line. Kind of looks like that road that we were looking at earlier with the yellow failure. So this is, or the retroreflectivity being low, which that was actually 90 millicandela. So we can see this line here, but as soon as we get back into the glare, you can see it disappears again. So this is a problem with AV. So what's the solution? Solution is, one of the solutions, one of the big solutions is going to be creating contrast. What's really cool is the cameras on an AV, they're representative of us. We'll get into LiDAR eventually and so forth, which will make a little bit of difference. But a camera basically sees very similar to what we're looking for contrast. They're looking for contrast. We're looking for color. They're looking for color to some degree. Color is really resulting in contrast is resulting color difference. Most cameras right now are black and white. I think they're moving toward color, but anyway, so they're looking for the same things that we are on the markings. So if we can't see the line, there's a good chance that the car can't see the line. I have experienced a little bit different than that. I have experienced the car actually sees the line a lot of times when I don't. But again, I have visual cues. The car doesn't understand those visual cues as well. So here, in this particular situation, if we were to contrast that line, if we were to take that and make that, like for instance, we found not leading, well, here, these are, sorry, forgot I had these images. So this is a contrast line. Now, frankly, that contrast line doesn't do an AV much good, is what we found, because it still can't, it's still not determined because it knocks out black. That's why it doesn't follow. Most cameras are knocking out the black, the negative numbers, because it's otherwise it'd follow crack fill lines and all that kind of stuff. It is looking for contrast, but it's looking for this lighter contrast here. This is a much better method of contrast when you box in, because now there's a delineation. It's saying, okay, here's the edge of the line, here's the edge of the line. So it's able to see this better. One thing that we've found as a problem is in the glare. So this is in a normal daytime situation. This is great for AVs. But in a glare situation, you also have the issue of this massive light being reflected, the sun's light being reflected off this surface. If the surface is the same straight across, and I want to thank Dr. Carlson for pointing this out from the last webinar we did on this, is that if there a lot of times contrast, the color, it could be purple, it could be bright pink, it doesn't matter. That light is so strong from the sun, it's going to blow that out. Really, about the only thing you can do is change the structure of what's around it, so that the retroreflectivity, or it's actually reflectivity that's happening, is from the sun, is actually going to be different on the line material, the line surface, versus the edge of the line. So that actually helps. Hopefully that was explained well. Stats. All right, so we told you a lot about the statistics. We told you a little bit about the story, showing you the pictures and so forth. We're going to stick with the S theme, successes, struggles, and surprises. Successes. Well, did you see the stats? We got a lot of information, very good stuff. It was comprehensive, useful data. We were able to look at it and determine, we found a lot of stuff, and as seen in the videos. Breakout of retroreflectivity, road type, line type, speed. This is all great for specifications, and we have already passed this information on to FHWA to help them in assessing their own numbers and how they're going to, how they look at retroreflectivity and pavement markings. Several visual references via the LLG7's video and personal video. We were able to capture a lot of what you saw those videos explaining, for instance, yellow turning white at night, how dangerous that is. So that was a success. Nighttime, daytime visibility difference. We captured a lot of that. You'll see in one of our videos we have the daytime yellow, and it was failing. And then we have, of course, the nighttime. And so it was really kind of cool to see the difference of what that line really looked like in both conditions. Autopilot usage, 92% non-interstate, and about 97% on interstate. This was actually partially a surprise as well. We were able to use the autopilot feature on the Tesla about 92% of the route. The only time we had to take it off was when we were having to turn, onto another roadway, or in a signalized section or something like that. And it was timely. We were able to capture all this information in just a couple days on the road. Bringing that up, I just want to show you, we support both handhelds and mobiles, but I just want to show you the difference here. So a mobile retroreflectometer, we used 1.5 persons. Why did I say 1.5? It took 2 of us to go up. Undoubtedly, 2 operators are needed. And now I understand I'm driving a Tesla here, so there is a difference, especially on the ride back. And it's not saying that Road Vista or any manufacturer is recommending only 1 person behind the wheel, but I can tell you that driving the Tesla on I-95 straight down in autopilot, it was completely operated by 1 person. And so the half person is when we used 2 when we went up on the trip. The total man hours that we spent was 37 hours. Total markings measured was 6 million feet. And we had a valid scan about every 4.44 inches. So every 4.44 inches, it'd be like if you were taking a handheld and you clicked it every 4.4 inches for 6 million feet. We were able to do this in right at 24 hours and 52 minutes of assessment time. If you were to do that with a handheld, it would take you 759 days with 3 people, 1 meter, and 1 handheld, and running 24 hours a day, 759 days. So it just gives you an idea of the power of mobile retroreflectivity. Struggles. Environmental. So stripe type and speed limits on urban roads. It was really hard, as I mentioned earlier. It was difficult. It was a struggle to figure out what type of I'm sorry, no, this is stripe type. So this is the line type. Solid skip. When we were on urban roads, there was a lot of decel lanes, a lot of 2-way center lanes, what we lovingly call suicide lanes, I'll get in trouble for that one. Anyway, so we have a lot of those. So monitoring, having to keep pushing that button, saying, okay, no, this is this type of line, this is this type of line. And it's not really because the machine needed it, it's because I wanted that data split out on a lot of these. So anyway, I did that. And then speed limits, it was kind of hard to tell when we were going to, all of a sudden we'd be like over 50 and we wouldn't even know it. It did help because the car does have a system in it that tells you what the speed limit should be. It's just not always accurate. Working around the weather, both two conditions that concerned us. One was the condition with dew on the roads early in the morning, working around that, making sure it got burned off before we started measuring. And secondly, was rain, of course. Yeah, we did get stopped. We were very blessed. It was pretty cool. We made a lot longer route up than we thought we would because it was supposed to rain the whole trip up, and it didn't rain until we got into Virginia, and that's one of the reasons that the Virginia numbers were so truncated. Was it rained, and we had to stop measuring the roadway. Next is I lovingly call the interstate idiots. It's amazing how you can be driving. I didn't have this problem on the state roads, but on the interstate, you're driving 70 miles. You're driving speed limit. I'm in the far left lane, of course, the passing lane, which is normal. I have strobes all around my vehicle. I have this meter with a strobe on it as well, and at night you can even kind of see the laser hitting the roadway, and it's strapped to the side of this vehicle, and people still were trying to run me over. It was pretty amazing. So yeah, that's always a concern. It wasn't a lot, but I had a couple that one of them was really serious. That a little bit of a road rage situation, I think. Anyhow, so yeah, you got it. Operation. So the struggle in operation was material type identification. This is what I mentioned earlier. It was just really kind of difficult at 50 to 70 miles an hour figuring out what kind of material we were over, if it was paint or thermal, or if it was a multi-component. Most of the roads that we were on in that particular route were not. There were no multi-component. Intentional line width of older markings. So we didn't know. We said one of the settings was, is this a 4-inch line supposed to be, or is this supposed to be a 6-inch line? I can look at a longitudinal line and tell you if it's the difference between a 4-inch and 6-inch. What I can't tell you is what it was intended to be, and that was hard. So we were going to tell you how many lines actually failed the width, but we couldn't do it because we didn't know what it was intentionally supposed to be to begin with. Next, as far as the LLG7, we had two times that we had a GPS connection issue. The one of the issues that we had, and it was only on startup, and it was where I had the problem with the Tesla is that when you go out of that car, it shuts all of its power down. And so we had an interrupted power shutdown on the LLG7 two times. And those times what it did was when it rebooted, because it was shut down as interrupted, the GPS didn't capture again. It wasn't like we were driving down the road and GPS went out. It just never fired up on the next time I started up the car and headed down the road. So that kind of stunk. I did talk to the manufacturer's Road Vista about this, and they were able to, now they've got a corrective measure in there to really make it clear, because I drove like 25 miles and I didn't realize that the GPS wasn't on. So you see a little gap in my mileage on my map at one point. Anyway, so we've got that solved. And then distance measurement was a little difficult. Trying to figure out exactly how long, what kind of distance that we measured, because I did not properly use the odometer setting that I showed you earlier on the screen. The Tesla, larger lanes versus autopilot versus the LLG7, or really versus any mobile. So a mobile retroreflectometer is a good one. I'm not going to say all of them, but because I don't know for sure, but they're designed to be a little offset. So that way you don't have to drive down the middle of the road and have this $100,000 instrument sitting in the middle of the road so somebody can knock it off. So you still stay in the center of your lane, you measure the edge of the line. Well, if that lane suddenly gets much wider, like we saw wider lanes, I think it was South Carolina, And the autopilot says, hey, I'm not going to hug you on either line. I'm going to put you right in the middle of that lane. So that's how it manages you. So when it pulled me over to the middle lane, all of a sudden my 3-foot scan was catching like the edge of the marking, and it was a problem. So I actually had to go out and do a slight change in positioning of the LLG7 for those wider lanes. I stayed within that, I believe it's 5% degree that you can go, but it was that was a struggle. Because again, the Tesla was putting you in the center of this lane. Also autopilot and raised pavement medians without skip lane markings. This was a phenomenon. So I told you 97% of the time and 92% of the time we were in autopilot. So we set up a button that every time AV failed, we would click it, and then we could go back and we'd say, okay, it failed here and here and here and here and here. You know, all these places it failed, and then look at the markings and get a good comparison. The problem is I couldn't get the autopilot to fail, frankly. I was very surprised by that, as you'll see. But where I did have a problem was for some reason where there was these raised medians, and it was just in this one area. I hate to keep picking on you, but I think it was South Carolina again, and there were these gaps between the grass. There were grass medians, but they were marked. Excuse me. So they were grass medians, but they were marked. And the car seemed to all of a sudden want to follow, the lines went around the nose of the median. So the car seemed, I guess there was such a gap or something between the medians that the car actually wanted to turn left. and it would catch itself. It'd be like, oh, you know, and kick off and so forth. But if there were some skip lane lines that would have went between those two medians, skip edge lines, I think it would have that would have solved the problem. Charging every 150 to 250 miles. Remember, this car gets about 250 mile range, but of course we're using charging stations that are specific to Tesla because they're so much faster. So you don't always go 250 miles between. Often it's only between 150 and 250 miles, these charging stations. So we had to stop several times. So that was kind of an issue. I'll be glad when these things when they get these, the distance much greater on these vehicles. All right, surprises, color failure. I was blown away by how much color failure there was. Ease of collection, it really was easy. Autopilot functionality, again, expected it to be a lot more failures. In fact, I'm kind of disappointed because I really wanted that correlation to check the correlation, but there was just really nothing to correlate. Higher average retro on non-interstate, especially being yellow. I mentioned that earlier. Lower average retro on interstate, again, negatively surprised. Number of new markings failing. That's heartbreaking. You know, agency spends, especially if it was a city county that spent a ton of funding, percentage-wise of their funding on a new marking, and yet it's still failing. That was disappointing. And we saw that both in retroreflectivity and color. Another surprise was color detection to separate retro measurements. So when I started out, I would, when we were in an urban area and you had a lot of D-cell lanes on the left-hand side and we're measuring the yellow, and I wanted to make sure that we didn't mix the yellow and white measurements, because that, if I told you all of those are yellow and then they were intermixed with some white, which would bring that retro up, right? So that was a concern. So I started out hitting, pause, go record, pause, record, pause, record, pause, going through these areas, and it really became annoying. And then I realized, hey, this thing's a color unit, so it knows what's white and yellow. So I was able to not worry about that so much. And in post acquisition, I was able to take and say, throw all these white numbers out, because there wasn't enough to be representative of anything. And throw those out, and we're only going to do the yellow. So that was really cool to be able to do that. The workhorse of the equipment, good gosh. I mean, I just figured, this laser 400 scans per second that is going to wear this thing out. And we were going hours and hours and hours of this thing constantly working. I was impressed. I mean, I like the machine anyway, but good gosh, I really expected to see I expected to see a failure. Honestly, I thought, well, at some point this laser's got to go out. It's working 8 straight hours. But anyway, impressive. Ease of acquisition overall, especially on the interstate. With again, the Tesla combined with the ease of operation of the LG7, it was just, in fact, another Greg in our office here did the measurement by himself coming back, and he did stop overnight. And he's like, I really, if I hadn't already made that reservation, I would have kept driving because it was just so easy to acquire these numbers. Next, the final S is spring of 2019. So the plan in the spring of 2019 is that we plan to do a coast-to-coast measure across America. So this was, as you can see, this was the pilot that we did, and we learned a lot. We learned what we can do and what we can't do, what our expectations are. So we're excited about going from Jacksonville to San Diego and then back across. And so this is going to be cool. We'll probably do like a southern route, I-10, and then maybe an I-40 coming back across, that type of thing. So we're really excited about this. It's going to be about a 2-week, 6,000-mile study. And what we're going to do on this trip is kind of cool. We're going to offer 25-mile city and county assessments and ride-alongs en route. Now, why are we doing this? Well, we know the states got it. They understand a lot of states are now having minimums put in. They're ahead of the game with FHWA. They're actually, the bet numbers are higher and better than FHWA. So it's a little different than we had the sign implementation of minimum retroreflectivities. It's kind of opposite. The states are leading this, and they're doing a really good job. Where I think we have concerns, where I have concerns, is the city and county assessment, or city and counties. I don't think they quite are there yet in understanding the importance of this retroreflectivity, and maybe not that, but just the accessibility of such equipment that can give them comprehensive information. But we're really wanting to promote better marking management on that local end of agencies. So that's why we're going to do this. Well, like I said, we'll do, just give us 25 miles of roadway. We'll do it. You can ride along with us. We'll give you a full report and everything, and let you see if it can help you, see if that city and county can make the road safer. We never want a city or county, we never want anyone to die on a roadway because the agency, no matter who they are, couldn't afford or didn't have access to make that road safer. And that's what we're promoting. We're going to incorporate a lot of lessons we learned from the pilot project. And we're going to present data both live and online venues. We'll probably be at a couple different association meetings presenting that data. We'll probably do the same with this, as a matter of fact, and that's going to be one of the questions we're going to ask you in the end, if there's any associations that need this data. Next is what we're seeking. We are going to be seeking some sponsorship by agencies and manufacturers to offset the study and expense. Those sponsors will be noted if they wish to be. And this, again, is a 2-week, 6,000-mile study, so there will be some expense incurred, and we'd like to get some partners for that. It will be a publicized event, likely getting a lot of media attention, and this, as a sponsor, it'll be a great chance for you to get the first look at the data and use it. Okay, so it's time for questions and answers, and as we get prepared for that, for the live version here, I would like to share with you also that we will we'll be providing you with a survey, and for those that download this presentation, or for those that are online with us now, you'll get a quick survey. We want some quick feedback that actually helps us tremendously. This presentation was actually better than the first one because we added a couple more slides and clarified some things that others may have found confusing in the previous one. So it always helps us. So we're looking for constructive criticism, and if you felt that this was something of great value to you. We'll also provide information on record a copy. We'll ask you if you want a recorded copy. We'll ask you if you want us to speak or share at your next event, and we'll ask you if you want a detailed webinar presentation on the power of the LLG7 mobile retroreflectometer. Also, if you want just a call to talk about your particular situation. Sometimes we feel that our agency is dealing with something that others aren't, and we might be able to share and help you with that. Gives you an opportunity to request that, opportunity to request a quote on a retroreflectometer and a quote on a Tesla. Well, maybe not the Tesla. We'll have to send you to Tesla for that one. Lastly, I do want to say that we have the videos that you saw were just clips of, I think, of some really good content, and that is on our YouTube channel. So if you'll go to our YouTube channel and look up Retroreflectivity Technologies LLG7, and you'll find that series of Measure Across America video footage, and where we just took little segments, and most of them are 3 minutes or less, of the road condition and what we were experiencing and so forth. Great experience share. So thank you very much, and God bless.